Hi everyone, hope you're having a good day. For today's warm-up, you'll find it in Canvas, so go ahead and print it or download it to work through this question. This is a review of what we did yesterday, so make sure you follow the 4-step process to do this 2-sample T test. Pause here, unpause when you're ready to see the answers. All right. Couple of things about this that I want to go over specifically. Remember, one is that when it says do the data give evidence, that means test. And then second, we have two groups, group 1 and group 2, which is what makes it 2-sample. And then third, the reason we know that it's a mean is, let's see, I actually want to undo that. Okay, let's just highlight that. The reason we know it's a mean is because it says here on average, and these are not proportions, so quantitative. So those are just some keys for how to determine. The next thing I want to talk about is your HA with the inequality. So I just chose to do group 1 minus group 2. I find it easier just to do the first minus the second typically. And what matters though then is how do we choose this inequality? And so the way I chose to make mu1 minus mu2 greater than 0 was by looking at this paragraph here. So it's important to read it. We want to know, does polyester decay more in 16 weeks than in 2 weeks? And I had group 1 as 2 and group 2 as 16. And so you might be wondering, how did I know to put a greater than sign? And so let's see, right here is the important part. Breaking strength is easy to measure and is a good indicator of decay. Lower strength, oops, I hate that. Lower strength means the fabric has decayed more. And so that means that in 2 weeks, we should have a higher score than in 16 weeks. And so we have mu1 minus mu2 is greater than 0. So I would imagine that mu1 is greater than mu2, or you can replace this with like 2 weeks and 16 weeks so you don't get confused, etc. And we think that it will have a lower score means more decay, so we think mu2 is less than mu1. So that's just how I do it to figure out the inequality. Sometimes I get it wrong and I notice that it doesn't make sense at the end and I can fix it easily. Go back to the beginning. Remember, we want you to check both groups for your assumptions. So we have our P and our A. And I often forget to do the alpha until I realize, so don't forget to add that here. And then don't forget to check for both groups. I do want to make a comment here. Whenever we have random assignment, then typically this 10% condition is not met because we didn't sample, or it's not met, it's just not necessary because we didn't sample without replacement. I wanted to just keep doing it so that you could see it, but technically it's not really necessary to do when you have random assignment because we didn't sample from a population without replacement. So I wanted to make that little note. And then, okay, for this S here, I want to show you how I did this in the calculator. So here's my calculator. You go to stat, enter, and I put group 1 and L1 and group 2 and L2. So then we can go to stat tests, 2-samp t-test number 4, and we put data because I did put those values in my list. L1 is my 2 weeks, L2 is my 16 weeks. Keep those the same. And then, like I said, I think that the inequality mu1 will be greater than mu2. And so just pick the greater than sign there. Always know for pooled and then calculate. And so what that does is it gets me the answer for T and the p-value and the DF, but it also tells me the X bar 1, X bar 2, S1, and S2. And so I still like to show my work, but I just use those values from the calculator to fill in the formula. So I kind of do it all at once. And then remember when you draw your curve, I want you to write the DF that you're using at the top of the curve and shade it appropriately. So hopefully you see how simple that can be with your calculator. And Statlet.com also has ways to do the, what's it called? 2-sample t-test too, if you look on there. But I'm going to focus on the calculator for now, since you don't get Statlet on your exam. Okay, so hopefully that made sense. And what we're going to do today is practice one more type of test, an interval, before we review and have an actual test on this. So today's activity is something involving goldfish. So if you're at school, you'll have 1 cup full of goldfish and an empty cup. You'll have a full-size straw and a half-size straw. And then you'll need, your formula sheet with table B and the actual worksheet for today's activity. So if you're not at school, I'm sorry, but you can follow along here in this video to get some of the data. So let's just go through this together while we're all at school. If you're at home and you have some straws and some goldfish, you can still participate. It can be fun. It's a good little activity to do. So feel free to get these materials out ahead of time. And let's get started. So what we're wondering is, does the length of the straw affect your ability to transport the straw from a goldfish from one cup to another? So basically, we want you to put the full cup of goldfish on the left and the empty cup on the right, about a foot apart. You can use your paper as a guide. And then I want you to practice right now a couple of times. You're going to take one of your 2 straws and you're just going to practice using it to move the goldfish from the left cup to the right cup. So you just have to use the straw as it was designed to be used to get the goldfish attached to the straw and then drop it into the other cup. So you can practice a couple times just to make sure you know how to do it. And then I'm going to put a timer on the board. We're going to do it for 30 seconds, and then we will switch. So before that, though, notice that we are going to do a match pairs experiment. That means that each person will use the full-size straw once for 30 seconds, and then the half-size straw once for 30 seconds. So we need to randomize the order of the straw size so that you're not just going to be better the second time around regardless, because you got 30 seconds of practice. So we're just going to say that half of the room that's closest to the window will have the full-size straw first, and the other half will use the regular size that's closest to the door, and then we will reverse for our second group of 30 seconds. So remember, if you're closest to the window, then you will use the full-size straw to move the goldfish from cup A to cup B, and then if you're closest to the door, you will move it. And so just take the room and cut it in half, and that's how you'll know who should go where. As long as there's half and half, that's all that matters. So I'm randomly assigning you to the groups that way. All right, if you're not ready yet, you can pause the video, but if you're ready, we're gonna go ahead and do the timer. So I want you to get ready, get set, and start. Okay, ding, 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 ding. Great, write down how many you got with the regular size straw. I got 14. I can't remember what I had put. So I'm gonna put 14 right here. And you did not get 14, you might have got something different. So put however many you got. So look at your cup on the right and just count the number of goldfish in there. Don't eat them just yet. We're gonna use it again. Okay, and then let's do the timer one more time. So now you need to switch whatever straw you were using. And don't forget, if you were using a half straw the first time around, make sure you put it in the half straw question. You could have been answering question 1 or question. So let's do it again. So move your goldfish back to the cup on the left. Get the other straw that you didn't use the first time. And ready, set, go. Okay, so now you're going to write down how many you got with that straw. Remember, I used the half straw that time, so I got 12. But if you use the regular size, make sure you put them in the right spots. And we're done collecting data on the goldfish, so you are now welcome to eat the goldfish if you would like. And if not, then you can just throw them away because your spit's probably all over them. It's kind of nasty. So don't be sharing them with anybody else. Okay, so what we would do next is if you're at school, you'll just copy down some of these. Everyone will just go to the board and write some of their values in. So I got 14 and then 12 as an example. And the difference between them, we're going to do regular minus half. Like I said, I like to just do the first one minus the second one, makes things easier. So 14 minus 12 is 2. And then we have some other examples that you can write down. So, I mean, everyone just write down theirs on the board and then calculate, make sure you calculate the difference for each. And if there's 27 of you, great. If there's less, great. Just fill in this as much as you can. And then you'll work with that data for the rest. If you're at home and you don't have goldfish and you couldn't get data as a class, and you're not like that, might be difficult, then I just want us to go ahead and start copying down some of these values. I have 11 and 10, the difference is 1. 15 and 10, the difference is 5. 8 and 8, the difference is 0. 15 and 12, the difference is 3. And then 11 and 12, the difference is -1. So it's important to keep the negative because remember, we're doing specifically regular minus half. It's key to write that down so that you know, and the order definitely matters. Okay, so we'll just pretend like we got a lot more data. And if you, again, are in school, go ahead and make your own dot plot. If you're not, here is an example of all the differences only. So we don't care about the individuals here. We only care about the differences because everyone has their own skills. Remember, this is a matched pairs experiment where each person was matched with themselves because you have your own goldfish transporting skills. And so we don't want to look at the group separately. We want to look at them together. Each person has one value attributed to them. That's the difference between their two numbers. So copy this down and copy the mean and standard deviation down too, since I already calculated those for you. And then just pause the video here and answer this question, interpret the mean, and then unpause so I can tell you a little bit more about these values and how we can use them. All right, so here's a couple of things. First, what does the dot plot suggest about straw size? So 20 out of 27 students transported more goldfish with a regular size straw. How did I know that? So let's write a couple of things down on here. This 0 is very important. This means regular equals half. That students transported the same amount of the same amount of goldfish with a regular straw as a half straw. Now, one example of that was the student who did 8 and 8, but someone could have done 15 and 15, and they would have the same score in the end because their difference is 0. So the skill level of each individual isn't going to affect the results because they're being measured against themselves. Then we have these 4 that did worse. And so that's going to be that the regular straw was less than the half straw. And then anything this direction means that the regular was better. And so the 20 out of 27 that did more are positive differences. So the order that we subtract really makes a difference in how we interpret the results. And then for our mean, on average, the student transported 2.07 more goldfish with a regular sized straw. Now I want to use some notation before you get too far into your activity. So first, the mean, this is the mean from a sample, but it's the mean difference. So I want to use the letter D to say mean difference. Some people use all four letters, D-I-F-F. I'm just going to be simple, we'll keep it as a lowercase d. Same thing for standard deviation. That's going to be S sub D for difference. And so that's key. And to get started on the next page, that will really help you as you go through the 4 steps of PASS to run a significance test. So number 5 says, do the data provide evidence of a mean difference in the number of goldfish? So remember, your statistic comes from the sample. So we already have our statistic of 2.07. And then remember, if we're testing, is there a difference? Our null is always no difference. And remember, this is one sample of differences, so we're going to call this a one sample t-test for mu, and you can use the little subscript d for difference still. So give it a try. If you get stuck at all, you can unpause the video to see some guidance, but I want you to try, 5 and 6, the 4-step process on a significance test, and then an interval, just the last 2 steps for the math and the interpretation on the interval. And then we'll come back together to debrief that in a couple of minutes. Okay, so if you don't have this little subscript, make sure that you add it to your parameter. So our parameter is the true mean difference in the number of goldfish transported. This is a one sample t-test for mu, and I'm just gonna say we can cross out, or we can add the word paired or cross out one sample and write paired, because we have one sample of data, but the data was paired, so we want to indicate that in our procedure name. So we have a one sample of paired data. And so we can just replace the word one sample with the word paired, a paired t-test for the mean difference. Now our assumptions and conditions, notice how I didn't make 2 columns and do one for the regular straw, one for the half-size straw. This is just one sample. And so we check all of these for the differences. So for the paired data or the differences. So notice here, these are the dot plot of the differences. I don't care about 2 dot plots, there's only one. Here we randomly assigned, again, the 10%, it's really not applicable because we sampled, we did not sample without replacement from a population. We randomly assigned instead. So it's really not applicable there. Don't forget your alpha. Now for your formula, this is a one sample test, so we're using the one sample t test statistic. I'm just going to add a little d here, a d here, and a d here, because that's the official formula, even though it's really the same formula as a one sample test, and the mean difference will always equal 0 for a paired t-test. The df equals n minus 1. There's only one sample. So just keep in mind this is all one sample stuff, and then our last S is the same as always. So hopefully you were able to do that. If not, just remember that this is a one sample procedure. So we've already learned this, And we did it when we practiced, I think we did, let's see, do AP Stat students get enough sleep? So you can refer back to that lesson to see the one sample rules. Now for number 6, this was an interval, a one sample interval, so I'm just adding the D here and the D there. And so we still only have one sample. We had 27 students, that's the one group. And we just use a regular, formula, and everything is the same. One thing I want to make sure you do is you say true mean difference, and that you indicate the order of subtraction when you interpret it, because if we had done half minus regular, these would be a negative interval instead of a positive one. So again, if you were in class, or not again, just FYI, if you were in class and you got your own values, none of our answers would be the same, but hopefully you could follow along with the formulas to fill in your own answers from class. And if you're not in class, you'll just copy what I have already. Okay, so we just have a really small little group of notes. So go ahead and write this down. Matched pairs is one sample of pairs. So you can tell when it's a matched pairs experiment, that's when you do paired t-test. Remember our procedure, we can replace one sample with paired if we want to. You don't have to. So I'll just write it. I won't cross it out. I'll just write it right above. There. And everything else should be pretty straightforward. So go ahead and pause to copy this down, then try to check your understanding. I'm going to help you with the calculator on that one, but you can try it first, and then we will go over the answer. All right. First, for number 1, a couple of things how to determine if it's paired or not. So that's what this first one is all about. And so we just have to read through. Each driver flips a coin to determine, so 20 experienced scuba drivers are recruited. And then each driver flips a coin to determine if they wear the new fin on the left foot or the right foot or vice versa. And then the time to remove each fin is recorded for every driver. So basically we have a left foot and a right foot, which makes it one sample. And that's how we knew to do that. And so it's for mu D, mean difference. For letter B, if you look at this one's really easy to tell because we have 60 white piranha fish, and then we have 82 white piranha. So that's 2 different sample sizes, which means it's clearly 2 sample. And then I just want to show you the notation. That would be mu W minus mu P. Oops, no, I don't know what it would be. Mu1 minus mu2, whatever the two. I think it was from a different decade, yeah. So mu1 minus mu2, difference in means. So mean difference in means have different symbols. And then this last one is pretty tricky. I had to read it a couple of times, but when you end up looking at it, she selects 16 2-hour time periods and randomly assigns 8 to the drum and the other 8 assigned the other drum. And so that's 2 samples. I mean, she could have done this one sample, but it looked like maybe she just did it with 2 separate groups of 8. So if they had done 8 time periods and they put each drum in the water at the same time, that would have been a matched pairs. Okay, so let's move along to the 4-step process problem. This is the one I want to show you a little bit how to do in the calculator. So I just want to go ahead and type in the values to my L1 and my L2. So I'm going to do that right now. You guys can follow along if you didn't already try this. So we're going to do stat, enter. I want to clear the lists that are already there. Just want to show you a couple of calculator tricks. So I'm going to type these numbers in. 5, 5, 4, 3, 5, 0, 0 to 11. Okay, then the next one we have 16, 23, 5, 7, 14, 24, 6, 3, 15, 12, and 0. So you want to check over and make sure you didn't make any typos. Hopefully I didn't. And then what we want to look at here is, if you look at this problem, this is about 11 subjects. They were each given a placebo or caffeine in different orders, and then they were measured on the depression scale. And so they had one number that we could get for each person, and it's the difference between them. So like I said, I always like to do the first one minus the second one. So what we can do to do that really quickly is go over to L3, highlight it so this box is black and it's blinking down here. And I want to do caffeine minus placebo. And this will get me all of the differences really quickly, which, as you can see, there's mostly negative ones, which shows that there is a difference in the depression score typically for these values, because they're almost all negative, meaning that with caffeine, they had a lower score on the depression rating than without. And so that is how you can interpret those. And what we're going to be doing is we're going to do everything with L3. So we'll come back to that, but let's look at what I wrote for my P. So it's one paired t-test, mean difference, so we have mu d, and then we have true mean difference in depression scores, and I did with, minus, without. Now, this is a really challenging part of the process, determine the order, the inequality. And so the way I knew what to do is right here where it says, researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. And it also tells us that higher scores show more symptoms of depression. So I think no caffeine will have more depression than caffeine. And so then I think caffeine minus placebo will be a negative number, because I'll have a lower score minus a higher score. It's a tricky idea, so it just takes some playing around with the numbers. And like I said, if you do the whole process with it backwards, you can fix it at the end. Okay, the A. Great. Now you can make this dot plot yourself from Saplet using the L3. So if we go to our L3, that's where all those values came from, negative 11, negative 18, etc. We can also go to second y equals. And I'm going to turn plot 2 off. I don't care about that one. I don't know why it's on. Okay, so we'll go back to plot 1. Second y equals plot 1 on. And you can choose the box plot with the outliers. And then we want it to be second number 3. So you don't have to always do dot plots. Dot plots are easy to draw yourself, but a box plot with an outliers works too. And then hit zoom 9. And that shows us that there is no strong skew or outliers, because the box plot will show us no outliers, and that's really helpful. But I just went ahead and drew the dot plot, and it showed me the same thing. So either one is fine. And remember, we're sampling without replacement here, so we don't have to check the 10%. If you do check it, you're not going to get points off. It's totally fine to continue with that check. Here is our statistical work. Again, I want to show you in the calculator some things to make it easier. If we go to stat tests, this is a one sample test, so I can choose t-test. We have data. Our null is 0 for a paired t-test always, and our data is in list 3. That's where all the differences are. So choose second number 3. Then I think I had a less than sign, so I'm going to change it to a less than sign right there. And then I'm going to hit calculate. Then all the stuff I have, I can get from this screen. So I have my t, I have my p-value, I have my x-bar and my s, and my sample size. And so when I fill in, I like to write the formula down first generically here. then fill it in, and I got those values from my calculator, which are right here, negative 7.364 and positive 6.918. So that was my X bar and my S, right from the calculator. My T, my P value, and then my DF is, remember, N minus 1. And so I just draw the curve and label the DF at the top as a way to show what that is. And then our last S is the same as it always is. So hopefully you got that part. You don't have to use the calculator in that way. With the L3, it just makes things a lot quicker if you want to. Hopefully that made sense. If not, just go to some tutoring and watch some extra videos. And I hope you guys have a great day. And I'll see you next time.